Okay, hello everyone. So, today I'm finally releasing the initial first public version of the Magicka Modding Toolset that I've been working on for all this time in the past few months. And I wanted to make this quick video as a showcase of what tools have been made and how we can use them, right? So I made a few showcases in the past, but nothing that really could lead anyone to fully know how to use the tools as they are in their current state. So it's going to be sort of like an introductory tutorial and how it all works together. So the first thing we're going to be doing, I'm going to be explaining more or less the primary objectives of the tools that we have. So most of this is oriented around map making. Okay, there are many tools that have been made, and you can create custom characters, you can make custom textures, you can change and create custom physics entities and stuff like that. But primarily, the main thing I wanted to do with this tooling was offer a way for people to first create custom maps and levels in Magicka so that they can make custom campaigns, challenges, and versus maps or anything they want. And the second thing that I want to offer was a common modding interface of sorts that makes it easier for people to manage installs for modding, right? So let's get started. The first thing I'm going to be doing is going to be opening a directory and using that as a sort of scratch buffer for this tutorial where I'm going to be creating a new project that we're going to be working on. So let me go over to my file browser and create a new directory where I'm going to be working on this stuff. So let's make it something like my mod. Okay, here we go. So I've created a new folder right here, which is going to be a folder where I'm going to be storing all the data as we go creating the mod. And we're going to get started with the tools that we have available. So the first thing I want to show is the abilities of the tools that we have at our disposal. The first tool that we have available, if we go over to Steam, we can right click on Magicka, manage and browse local files and go into the content directory. And I'm going to go into levels and textures, for example, and pick any random surface texture. So I'm going to pick something like, I don't know, this directory right here where we have stone textures, right? So if we go over to this other directory, here's where I've got all of my tools, including the GUI tool, this one right here that I showcased in a previous video, right? And I've got a list of versions, profiles, mods, etc. And if we go into the GUI program, we go into release, we can go, well, actually, here I've got an older version. Let me go into the scratch buffer one, and this is where I've got what I want. Give me a second. I'm gonna patch my tool live with the modern version. So let me just delete this thing, put MPUP in here. Okay, so this is the modern version of the command line utility for compiling and decompiling XMV assets. So we're going to be doing a little bit of command line work in this video to showcase all the possible ways that we can do stuff, right? So if we open up a command prompt in here, right, we can go ahead and put this tool right here. We got MagickaPUP.exe, right? If we execute it, you can see that we got a list of commands right here that tell us what are the things that we can do with this program, right? So by default, if you don't input any code at all, any flags to this program, because it's a Unix-like command line utility, so it works based on command line flags, right? Everything about the program, you're gonna specify when you launch it through command line flags, right? So those arguments are going to determine, as soon as you launch the command, what files you're going to be processing, what type of data you're going to be decompiling or generating on compilation or whatever, right? You don't have to navigate any menus. The program doesn't wait for any input from a standard input or anything like that. And the reason why it's built like that, it's because I want the program to be able to be used in smaller scripts or be easier for users to customize their experience without having to wait for the program to without making the program having to wait for the user to write in something which would make it more error prone. So you can create a custom compile my mods button if you want with a batch script or whatever, right? And you can have a list of all the commands you want to input for compilation. So by default, it doesn't do anything, and it shows you the help screen, which right here displays all of the available commands, right? We also have a help command. You might think it's kind of useless because if you don't input anything, we have the help screen displayed directly. The use of the help command is that if you write anything, for example, we can do -p whatever, right? And we know that this command does not exist. It's gonna fail because this path is not real. Well, we can always say, okay, I'm not sure what I'm doing. Let me put -h without deleting anything else from my command. And automatically, it's going to ignore every single other command that I issue to the program, and it's only going to pay attention to the help command, right? So this is a very common behavior in Unix utility command line tools, where inputting the help command as a flag makes it so that the program automatically ignores everything else. So that you don't have to delete what you type, but you actually prevent any issues where you could break your program or fuck up your system by making some file operation that you really didn't want to do, right? So let's go ahead and talk a little bit about the things we've got available, right? So the program has different flags which have two forms. They have the short form like -h or the long form -help. In case that you prefer writing explicitly what the flag does rather than the short one, right? So these shorthands are pretty good once you memorize what each of them does to write commands more quickly. But if you don't remember them, you can always go to the help screen, or you can just type the long form, right? Basically, whether you type -h or -help or -p or -pack, it doesn't matter. Both do the exact same thing, right? It's different names for the same argument of our program. So let's get started with the two primary most important commands, which are the U and the P commands. So we got pack and unpack commands. This is basically the compile and decompile command, right? So as you can see by the description of the command, it's very intuitive. The pack command packs JSON files into XMB files. It's kind of a lie. It actually packs JSON and PNG and JPEG and any other type of file system input file. So basically, this compiles anything that is not an XMB file into XMB files, right? I have to update the description of the command because this was written a long time ago when the tool was first started being developed, when it was only JSON files back then. Nowadays, we can work with many different types of image files, right? Like you can even support, actually this tool supports JPEG, VMP, etc., right? Apart from PNG. And there's plans to support even DXT files in RAW, which is what Magicka uses for the textures internally, but that's another story. Anyway, and the unpack command does the opposite. It decompiles the XMB files into JSON files, and of course, if it's an image file, it automatically unpacks it into PNG files so that you can visualize it and edit it easily, right? So, most commands here you're not really going to be using. You probably, if you're going to be working from the command line, going to be using these three commands right here: the -indent command, the pack and unpack commands, right? So let's get started and do something simple. We're going to go ahead and decompile this directory right here, which is the one where we got a bunch of textures in XMB form, right? So we can go ahead and copy this path, and we're gonna say that I want to decompile these assets somewhere. Where? Well, we could go into my scratch buffer directory, which this is not important. This is just a name I gave to a folder where I do some little tests. You should not have a folder named scratch buffer with this exact notation for this to work. This is just like a folder that I personally made to quickly make some edits and some tests with different programs and files like that. Like this stuff right here is just my testing ground that I can just delete at any moment, right? So we can make a folder right here which says, for example, my textures or something like that, right? So if we go to the command line utility, we can put it MagickaPUP.txt, and we're going to use -u or --unpack, whichever you prefer. I prefer -u because it's shorter to type. And we can put in the directory from the origin, and then we put in the destination, right? So that's the order in which we work. We put in first the origin, the thing that we want to compile or decompile, and then the directory where we want the output to be located. right? So if we execute this command right now, it's going to start working, and well, it's going to show a bunch of debug data, because I like adding tons of debug data in case that anyone wants to figure out how the tool works or debug any issues or bugs or errors that could be happening within the code, right? And you can see that in this directory right here, we've just generated a ton of PNG files. So if we check the original directory, it has 85 elements, which are all the XMB files we have for the game. Right here, we got 85 elements as well, which are all the PNGs with the textures decompiled, right? So we can do this with any other type of XMB file within the game, level models, we can do it with character XMB files, etc., right? You can basically pick the base directory of Magicka and it will decompile everything. And obviously it will fail when it finds a type of XMB file that it doesn't know how to process yet. For example, the shader files are still experimental and they are not in MagickaPUP's public release version. So it will stop decompiling when it finds a XMB file that it doesn't know how to process yet. So I recommend that you decompile directories of types that you know are going to be working as of now, right? In future versions, some months in the future, when I get time to keep working on this, I will finally add the experimental support for those XMB files to the main version, so you will finally be able to decompile the whole game without having to go manually tweaking files and stuff to get it to work, right? So for the most part, it's pretty automatic. You can see all the results here. And now we're going to go ahead and look at the pack command. The pack command, that's the opposite. We can go ahead and pack everything within a directory or a specific file by name if we want. Same with the unpack command, right? Into an XMB file. So we could go ahead and pick this concrete texture, for example. We can edit it and we could say, okay, I don't like this being like that. I'm going to change it into something else. Well, in this case, we're going to just make a few red lines in here and we're going to save the texture file. It's right here. And we can go ahead and say, okay, I'm going to go and MagickaPUP.exe. I'm going to pick this directory. I'm going to pack the concrete0.png into a file named concrete0, right? So here you can just type .xmb if you want, but you don't have to. You can just type the name of your target file and it will automatically determine what extension it has to be, right? So we can just press it compile and it says, sorry, it says -p, I forgot about it, yeah. You have to add the command, my bad. So we ask -p to specify we want to pack this file, so we're going to be compiling the concrete0.png file into the concrete0 file, which is going to be an XMB file. So we can just go ahead, finish writing the XMB, and here it is, right? So we can open this app with Notepad, for example, and read out the XMVW, Microsoft XNA content, texture to the reader, blah, blah, blah. This is all the data right here for the texture, right? And that's the XMB file itself. And if we want, we can now go ahead and unpack this file right here. Let's go open up the path. And it's concrete0.xmb. And we're going to unpack it into, for example, test.png. Or we could name it AAA test so that it appears at the top, or we'll just AAA test, it automatically picks the extension, right? And here is, you can see that we got the exact same image file back, right? So we can open it up and we can look at it and it's the exact same texture as we had before, right? So if we edit it and we zoom like quite a lot into the corner, you can see that both images are identical. Like there are no difference between both of them. But there is an important detail that I wanted to mention, and that is that this file right here, right, the original one was a bit lighter in weight, but after I edited it with Paint, Windows compiled it into a PNG file that had 119 kilobytes, right? And this is the one that we generate from decompiling the file, which is only 77 kilobytes, right? PNG is a lossless format that has compression support, right? And you can write a really good PNG compressor or a really bad PNG compressor. My program, I try to use to the best of my abilities, the compression system that the bitmap class offers in C#. I know I can do better if I write my own, but this will come in a long future, right? Because even libpng, the official PNG implementation, doesn't really do proper PNG compression itself. But as you can see, what I'm trying to say here is that the files generated by MagickaPUP are actually far more compressed than the files generated by Paint or Windows or most other graphical programs for editing image files, right? So the data is the exact same because it's a PNG, right? That's why this is the default file format. So yeah, but if you want, you can also go ahead and save this as a JPEG, and it should work just fine because it also has support for compiling JPEG files. But yeah, anyway, we've already gotten pretty used to this command line tool. You can see it's pretty simple. If you want to speed up compilation a little bit and you don't want to see all the nonsense going on the standard output of the console, you can always add the debug flag. For example, if we go into MagickaPUP exe, we can see that there is a -d flag right here, which sets the debug level. If you say -d0, you completely disable or debug messages in the program, and since it won't do any standard output messaging, it will decompile and compile files much faster, but you lose the debug information. So if you're having trouble and you're having some crashes going on, or your file fails to compile or whatever, use the don't use the -d command, or use -d and a really high number to make it show like -d3 is the max level, if I recall correctly. I don't think I added any level 4 debugging options out there, right? It should show all the debug information during compilation, and then you can send that information to me and tell me, hey, my program is failing to compile this file that I wanted to add as a mod into Magicka, right? Can you take a look at the message and see what the issue is? And I can debug the error with that. But for the most part, you want to disable debugging because it's going to slow down the program, because it's going to be adding a lot of standard output messaging, and the console in Windows is pretty slow. So we don't want any of that slowdown. So let's go ahead and show what I mean by decompiling a XMB file right here. We can go ahead and say, for example, let's pick the arena XMB file right here. This is the one that we want, right? CH having the arena. So we're gonna go MagickaPUP, and well, we've got the my textures directory here. I'm gonna add a new directory, which is my levels, for example, or something like that. You go MagickaPUP, MagickaPUP -u ch Havender arena xmv into my levels, and say, I don't know, arena or yeah, whatever, arena, right? So when we decompile this, you're gonna see it was pretty quick, but all the debug information has slowed everything down for us. So we can just go ahead and add before all of this -d0 to make it so that it will not add any debug information, right? And I will briefly explain why these commands must go before the -u command, right? Because this has to do with the philosophy of this command line tool's way of working. So we can do it, and it finished almost instantly. And here is the file generated, right? It didn't really show any debug information on the console, so it was much faster, so because it didn't have to do any standard output communications with the console window. So here it is, right? Now, if we try to open up this JSON file, I'm gonna open it with VS Code because it's pretty large. You can see it's really fucking annoying to look through this file because it's a one-liner. You can see this is literally line 1. There are no new lines. The only reason we're going to the next line is because VS Code by default makes automatic line jumps when it reaches out of the window. But if we use any configuration to change that, or any other text editor, you will be able to see that this is actually a single giant line. But why? Because JSON files are minified by default with this program, right? So there are no spaces that are useless here. There is no white space. There is nothing. So this is the most compressed form of the JSON file. You can see that it's all human readable, and you can edit it if you want, but obviously for map files this is absurd. For character files, it's much more easy to do because obviously it's easier to configure that. But here, we got all the data for a vertex buffer, and editing this by hand is insane, which is why the MagicCow tool exists, right? Which we'll be talking about that in a while. So if you want to be able to read this data manually for debugging purposes, to extract some information that you may not be able to extract some other way because my tools don't offer it yet automatically or whatever, you can go ahead and use the -I command. So we go ahead and Magicka -H, you can see that there's this command right here, which is the -- indent, which sets the indentation level for our commands specified after this one, right? So this is the indentation level for the generated JSON files. So we can go ahead, grab the same command as before, and apart from the 0, we can -I true, right? So we can execute this, and now if we go back here, you can see it's now frozen because it's reloading the file. It's gonna take a while because it's a relatively large file, but as you can see, it's now indented. It properly has indentation, it has new lines, so a program like VS Code or any other text editor can properly parse through this, and you can read the data in a much more beautiful way, right? So it's much easier for users to understand that. So you can see all the content type readers in here, which, by the way, when you compile a file, you can just remove all of this data. This is generated by the decompiler so that you know which content type readers have been added to the program when you decompile the file. But when you compile a file, MagickaPUP automatically adds these content type readers as they are required as it goes compiling file, and it says, oh, I found this type of data that requires this content writer and content reader. I will add it automatically as a header. So you don't have to worry about doing any of this, right? As a matter of fact, MagicCow, the level editor, does not generate any of this data because MagickaPUP generates it automatically, right? Like, this is only useful when you're decompiling files and you're reverse engineering and you are like, okay, I want to add support for this new type of file. So users should not care about this ever in any way, shape, or form unless they're making custom modifications to my program because they want to make a fork or they want to make support for a custom data type or whatever, right? So we can ignore this section right here, and everything else is right here, well laid out. So you can see we can just go closing everything, and we've got the entire level model file format completely reverse engineered, and it's laid out in a beautiful JSON file. Well, beautiful, ugly as fuck actually, but it's really easy to read for users, right? So you can see that we got a generic division for all XML files into a primary object and shared resources, and we can have the primary object be of any type. In this case, it's a level model, and we have the model with the number of roots, the root nodes, etc., right? So this is pretty nice stuff going on. You can see that we have a way to inspect all of the roots that exist. We can see the properties such as if it's visible, if it casts shadows, the sway, the entity influence, etc. Each root is a different mesh in the scene, right? That is from the static level geometry, and we got 5 animated level parts in here. So we got a rope, we got another rope, and there's a grate with animation, which I think doesn't actually ever happen in game, but the grate in the arena actually does have an animation, which we'll be looking into right now. Actually, it's a curious thing that I wanted to showcase. So pretty cool stuff, pretty nice. Let's go ahead and now talk about compilation, right? When we want to compile a file, we can just do for the JSON stuff the -p command, as I said before, and it works the same. We generate an XML file for the level model, so that's pretty nice. So for the command line utility side of things, I think I've shown everything there is to know about Magicka. Oh yeah, of course, that's the thing. I forgot about that. Yeah, that's another important thing. So MagickaPUP, as I said before, you have to input these commands before the U or P command because these are modifiers that affect everything that comes after the command. And you may ask why. Well, because most compilers can only affect one single file at a time. For example, GCC only affects one C file, so we could have something like gcc main.c, and you could either say -o main.exe, or you could say -o main.exe, and both would mean exactly the same thing, right? Or you could say main.o-c or -c or -c, right? You can basically put it in any order you want because you're only processing the generation of one single output file. In the case of MagickaPUP, you can chain the command and put multiple files that you want to process. So I could, for example, pick individually I don't know, let's say I pick the Necro preview XMB file, which is an image preview for a file, right? So we could say -u, this path right here. Well, let me go ahead and open Notepad so that you can see in a more clean manner what it looks like. We can see here magickaPUP.exe, and we would have this command right here, and we could say -u and pick this Necro preview, right? And put it into this directory right here, for example, right? And we can then also say -u and add another command. So we can also, for example, say I want to decompile a XMB file for some other map, for example, the Vietnam map. So we can have this thing right here with the string library, blah, 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 right? And put it into this other folder right here. And say Vietnam.case, right? Or no extension if you don't want to. This command, I'm gonna remove the new line stuff. You can see it's much longer. We got the program itself. We want to unpack this preview file into this other location right here. We also want to unpack the Vietnam map into another location. Now, if I wanted, I could say add like 3, 5, or 500 or as many as I want commands in a single line, and I could even issue a compilation with -p commands at the same time in here. So I could have something like packing and unpacking different files in the same compilation unit, let's call it, or execution of the program, right? That way you avoid the overhead of booting up the program multiple times. If you want to write custom compilation scripts of your own for this program, you can do it like this. And what we can do in this case, imagine I want to be able to generate this map with indentation enabled. So we go -i true. And we can also say -d0 so that we disable the debug output, but I want debug output enabled for the preview XMB decompilation there. So we can say -d2, or we can write nothing because by default it has it, but -d2 for example, right? And maybe let's say I want to decompile another map with no indentation. We can write another command and then we have -i false and then -u whatever, right? So now that we've got this pretty long command in here, we can go ahead and type it out, and it's doing its thing and it finished, right? So as you can see, the image performed debug output, the map didn't. If we go to my levels, you can see that we got the Vietnam JSON file. We got the preview right here, so we can open it up. This is the one. And this Vietnam JSON file, we can open up with VS Code. And it's going to take a while to load up, but you can see that it's going to have indentation enabled, right? So it's pretty weird, I guess, for people who are not used to using command line utility programs. It may seem like a lot of noise and weird stuff, but these decisions are important to me because it makes it easier for people who don't want to use a user interface to work with these tools more cleanly, I guess we could call it, right? So yeah. Now that we're done with this showcase of the command line tool, let's go ahead and look at the user interface program a little bit and the map making. So we're gonna go ahead and open Blender now. We're gonna be working with the MagicCow add-on. So it's loading up. Great. So in this case, what we can do now, I'm gonna go ahead and say, hey, let's imagine we've got this new map that I want to make, right? So one directory that I have that I wanted to show you, give me a second. I've got myself prepared. No, not this folder. It's on F, my stuff to Magicka Playground. Okay, so I've got this directory which I called Magicka Playground, where I've got basically all the content directory from the base game copied and pasted in here. And then I went to levels and textures and decompiled every single texture. So I've got the original file and the decompiled files as well, right? And I did the same for the levels. So if we go into challenges, for example, you can see that we got the decompiled JSON files for many levels. We can go into levels. Wizard Castle is completely decompiled and stuff like that, right? So this stuff is important. I'm gonna go ahead and showcase first the import capabilities of the program. So this program, Magicka, well, on Blender, the MagickCow Blender add-on allows you to both export and import JSON files for MagickaPUP, right? So for the export option, we can, for the import option, we can import decompiled files so that we can explore the scenes from the base game, right? Or any other mod made by someone else. So we can decompile XMB files and we can then import it into our scene and explore them to look at the map, right? So we can go ahead and say, okay, let's import this JSON file and let's go over to the Wizard Castle directory. So I'm gonna copy this path, I'm gonna paste it in here, I'm gonna import for example, Wizard Castle #1, right? So if we go ahead and import this file, it's gonna take a while, and here it is, right here. This is the map, the first map of the video game. You can see that everything is imported. You've got the geometry for the level, you got stuff like collisions, the actual meshes, the points of interest, which are POI's point of interest. These are the things that you can interact with, which are actually bones, right? You got the locators for spawning entities. You've got triggers on the scene, so we can go ahead and say, yeah, there's a trigger in here. Let's pick it up, right? You got another trigger in here. You got particle effects. You got everything basically, right? The importer is not finished. There's a lot of stuff I want to finish up for the importer and the exporter as well. But as you can see, it works pretty much nicely for like 90%. It's 90% of the way there. The things that are left are just details to make it a little bit better, like quality of life stuff that I will be working on in the coming months in the future when I have time, right? So with this importer, you can pretty much just extract any of the base game assets to use on your own maps if you want, right? For example, let's say I want to use this pot right here or these sausages. I can just click on this and say, okay, I want the cheese, right? We got all the cheeses in the game seem to be joined into a single mesh, except one over here that is interactable, if I recall correctly. There was one that had a point of interest. I can't see it, but if I recall correctly, there was a cheese that was separate. Or maybe it was the sausages. Yeah, like you can see that all the sausages together are merged, except this one, because point of interest objects are actually animated level parts, technically, under the hood, so they don't get merged. The reason they are all merged together by Magicka is for performance reasons, so that they can share the same vertex buffer and they can apply the same material effect to these pieces in the map, but you don't have to do it like that, right? Like, it's not really necessary. It's just an implementation detail of how they made the maps originally when the Magicka developers edited the levels. So yeah, anyway, we could just take this, for example, and say, okay, I want to make a prop with this. We can select this, select, invert, we delete everything else, and we can, for example, select the base, cursor to selected, origin to 3D cursor, and now we've got a custom prop that we can use in our maps, which is a pot, right? With like a vase for water, you know, or a jar. Sorry, that's the word in English. Now, you may be looking at this and saying, okay, but this is all black and white. I don't see any textures. We can go into texture mode. You can see it doesn't look like there's anything here. Uh, I will be explaining why. If we go into render mode, you can see that the lights are actually working and they look more or less. I edited it so that it will look as close as possible to what it looks like in game, but nothing can be perfectly one-to-one between Blender's lighting model and Magicka's lighting model. So yeah. But anyway, what I'm going to explain now is how to get textures working, right? So this will be changed in the future, but right now, if we go over here to the scene panel right here, properties, we got different things. We got a window called MagicCow scene configuration, right? Everything else is default stuff from Blender. This right here is a scene configuration option that I added for the MagicCow add-on. And you can see that we've got multiple options. We've got right here the scene display settings, so we can change the display object tags. So if we unclick this, you can see that the object tags are gone. We can change the synchronized display state. This is a stuff that you shouldn't really want to touch because it's like related to the way that the tags are displayed, so it's just for visualization purposes. Here is where the important stuff begins. If you're going to be exporting your scene, you've got the scene export settings. The mode changes what type of object we're going to treat the scene as, so we can have the scene be treated as a physics entity or as a map. I will be adding support in the future for treating it as a as an animated model for a character, so that we can create custom character meshes, but right now there's no support for that, right? It's just that I don't have time to do everything all the time. So yeah, if you hover your mouse on top of this, right, you can see that there's a little description for every single property. You can say synchronize the display state when the internal state of Magicka object configuration, useful for visualization purposes, blah blah blah, right? And you can hover on top of this option so that you can see what type of scene mode we're going to be working with, what each of them does. So if you have any questions about what this option does, if you see an option from my add-on and you don't know what it does, you put the mouse on top of it and you will get a description, right? And with this description, you can see what is it that it does. And if you don't understand it, then obviously you can always message me and ask for clarification, or you can play around until you figure it out, right? So let's change the export mode into map. You can see that now all the tags update automatically, so we can display them or not synchronize the display state. This is for changing if you want to set a specific object to have a different display. For example, the empty, we can change it to be a single arrow if we want. And if we change the mode to trigger again, it will update automatically to a box, right? But if we go into the scene properties and disable the synchronization, it should remain with this shape no matter what we do, right? So I don't really use that option, but it's there in case you need it, right? On the scene export stuff, you can enable exporting animation data if you want. This is disabled by default to speed up the compilation, because maybe you make a map that doesn't have any animations at all. If you want animation data to be exported, you need to click this option. I will change stuff in the future. Base directory, you can ignore that. It's going to stop existing in the future version of MagicCow, but the gist of it is that it was for external JSON files for textures. We'll talk about that later on in this video, right? Here, JSON export settings, obviously, you can put in the format and you can change the character use if you want to use tabs or space, how many spaces you want to indent, etc., right? So this is pretty much just a way for you to configure how you want the generated JSON file to look in case you want it to be debuggable. If you want to be able to read out the output in a human readable way, then you put in the format. It's going to make the JSON file take up a lot more space on your hard drive due to all the extra spaces and new lines, but it will make it easier to debug your map in case that you're having any trouble understanding an issue that's coming up, right? And we can go ahead and see this is what we were talking about, which is the textures. On the scene import settings, we have a button that says import textures, right? In the future, I will be adding parity between the import settings and export settings. So I will be moving out, I will remove this, move out the async export mode is technically the mode of everything, not just the export mode. It's just also the visualization mode. So I will add it to another window, which would be async mode on its own window, and that's it. And then we will have an option to enable importing and exporting animation data, import and export texture data, because right now you can see there are no animations on this scene. But if we go ahead and import a different map, let's go ahead and delete this and import JSON. We can pick up, for example, what's it called? We had in challenges the oh yeah, we got the stars are left. We can pick the last map, right? The boss fight map. You can see that there's animation stuff in here, and we can play the animations. These are the animations that exist in the game. This is the at the end of the game where when you beat Cthulhu, you can see that the rocks start falling from the sky. Well, that's basically the animation that happens inside, right? The rocks slowly slide into the window and then fall down. So yeah, by default you always import animation, but maybe someone doesn't want to import animation data, so I will be adding a button in here to disable that in the future, but for now that's okay. Right now we were going to talk about the texture importing, right? So when we enable import textures, we can go ahead, import the JSON file, and we can look for Wizard Castle number 1, right? And once the async is generated, we can go into this display mode, and you can see that we've got the textures in here. Now, calm down, don't worry. This message right here, if we go over to their materials, you can see that in the MagickCow material properties, they are meant to be black, but they are not. These are like the black background parts that Magicka has in these levels, right? But this is not fully implemented yet. I will make some changes because I haven't implemented it because I wanted to make a custom node for materials to display the fur effects, additive effects, etc. in a more clean way, so we can get rid of this panel. So this panel you're seeing right here is a bit convoluted. It will stop existing in the future, and it will be replaced with material nodes instead, right? So don't use this because it doesn't work for export either. Only importing works here. Exporting does not work, so it's not really nice. But basically this looks white only because of that. And the rest of the white shapes that we have, these are the nav mesh and collision meshes of the map. So we can go ahead and look into the collection. Whatever collection we're clicking on is the one where the data will be generated when we import it, right? So we could create a new collection here, press this one, and when we import this thing, it will be added inside of this collection, right? So let's just delete it and go in here. You can see that we've got a ton of parts. You can actually see how many meshes. There's 127, 131 objects, 127 empties. This is the meshes, 54 lights, etc. Right? And you can see that stuff that has a name, such as locators, particle effects, etc., they conserve the exact same name they had within Magicka, right? So you can see they've got their names just like that. And the stuff that are lights also conserve the exact same name that they had within the Magicka scene, right? Animated level parts also concern the name. You can see we've got the point of interest and stuff like that. But as you can see, when we generate the meshes, they don't have a name attached, so they are just named mesh 0, mesh 1, mesh 2, whatever, right? And they are the different meshes in the map, but they are textured. But you can see the sea fighting right here. That's because there's in Magicka, the meshes are separated into the visual part of the geometry and the collision part of the geometry, right? So eventually we will see stuff named collision whatever, right? So if we go over the thing, at some point it should be in there. I can't read it. Here it is, right? You can see that we got collision mesh model 0 generic, collision mesh model 5 stone, right? So all collision mesh, the names that they have is 0, the number of the collision channel internally used by Magicka's engine, so that they are all together ordered one after the other. And after that, the name, there's an underscore and the name of the channel so that you know what the number corresponds to. So this is for ordering purposes, and then The name is for visualization purposes. So you can see that in this map, we only have two types of collision, which is generic collision and a stone collision, right? So we can grab our stone collision mesh and you can look at it. It's basically the outline of the map without the carpets. And these are the collision meshes for basically everything in the level, right? And here we got this other mesh, which is the generic collision, which includes the tables, the carpets, etc., right? And the tables, for some reason, are generic rather than wood, but, you know, that's okay, right? So we can just delete or make invisible these collision meshes. We don't care about that. This right here, if we look up nav, is the nav mesh that was generated, right? So this is the mesh used by the NPCs in game to walk around the scene. You can inspect how they look like in the base game to get a good idea of how to make a good nav mesh of your own. As you can see, they basically try to prioritize having very big triangles, and they try to have a little bit of margin against the walls, and there's basically one vertex on every single corner. This triangle is pretty bad for the nav mesh actually, so we could even try to optimize the generated nav meshes for Magicka and make improvements in the game, but you know, that doesn't really matter for us. So we can go ahead and make it invisible, and now you can see as we go making more and more objects invisible or removing trash geometry that we don't need from the map, you can visualize the scene much better. We can disable all the text elements, and you can see that the scene actually imported all the textures just fine, right? So every single piece is in here on the level. You can see it. It's pretty nice, right? And with this stuff, you can now create your own assets if you want, and that way you can just create custom assets that you can use on your own maps in Magicka, right? So with this stuff into account, I want to explain how the texture importing works, because you may try to import your textures and you will get an error. You can see the import texture button right here. Well, for this to be able to work, you can see that we've got the Wizard Castle file in here. This is the one that we imported, the JSON file. Well, since Magicka uses the, well, let's explain what base directory is first. So base directory is inspired by the way other video games work. Most of the time, video games use a system where assets such as materials, textures, and other meshes are referenced with a path relative to the location where the game data is located. Right, so you got the executable, and usually got something like content, game data, base, whatever the name of the directory is. The thing is that inside you got the assets of the game, right? And they are referenced as absolute paths relative to that path, right? So they may be something like game content slash assets slash whatever, textures, my texture.png, right? Or anything like that. Magicka does it differently because it uses XNA. In XNA, usually when you create assets, the meshes reference textures and materials as relative paths to the asset itself, not to the content folder. So what that means is that the data inside of the material effects on the scene have a path that is relative to this file itself, right? So we got this file in here. And if we inspect the JSON file, we can open it up with VS Code. Well, it's not properly indented. Let's go to the Vietnam map, actually, because it's actually indented. I'm sorry about that. So it's going to take a while. But you can see, if we close up the content stuff on the primary object, we can see on shared resources, we got an example of a material. You can see that the path doesn't say content slash whatever. It uses ... This is telling the program that it wants to go one directory up, then it wants to go into the texture directory, object, the structure, radio tower, right? So if we go over to the challenges directory, which is the Vietnam map is located, we ... So we go to the directory before challenges, we go into the textures directory, we go into object, we go into structure, and here we should have one called radio tower, whatever, right? So it's somewhere around here, and here it is, radio tower 00. And it doesn't use the extension because XNA assumes that every single asset that you reference is going to be an XNB file. So it adds the extension on its own to reference the file. So you can't cheat the system and use a PNG or anything like that. It has to be an XMB file that is referenced, right? So what this means for us is that when we try to import a map, we are going to have to 100%, if we want to get correct results, have these files located relative to the file we are importing, right? So as you can see on my Magicka playground, I got the Wizard Castle file. If we go to levels, we go to textures, we can go into object structure. You can see that everything is decompiled in here. So this is the location where Magicka is looking for these textures. And if you did not decompile the textures and put them in the relative path, then it's not going to find them. But don't worry about this, because this is really easy. You just grab your content directory, you grab levels, and you decompile everything on the levels directory with MagickaPUP, and that's it. You should get everything you need for it to work properly, right? So yeah, that's just an implementation detail I wanted to explain in case people have trouble getting textures to work. Basically, it works with a path relative to the location where the JSON file is located, right? So yeah, that's basically all there is to it for importing stuff. So yeah, this video was like a showcase of the stuff that we have available. For the tools, more or less, to get a hang of how it works. I will now be making a much shorter and better video where I'm going to be making a small map as a test for people to, know how to use these tools for what they actually care about. So this was more of a technical overview of sorts, where I explain how the tooling works and the things that we can do. So yeah, see you in the next video, and thanks for watching.